Hello, ladies and gentlemen of geometry, or people of geometry, I should say. This is a little bit different than kind of what you're used to. This is solving systems of equations. And you've seen this before in algebra, and you'll see it some more in algebra 2. But this is just a quick review of kind of how to solve those. So one option is by substitution, and that is where you basically have a variable that is kind of by itself, or you have something like, x equals, y plus something, or, you have y equals, x or 3x plus 12 or something similar like this. So you can substitute this in for y in a different equation. So let's kind of see what that looks like. Just a reminder, if you have something that is true, so if you're working along and you get something down to like, 7 is equal to 7, or, a equals a, that's true. And that is your clue that is infinitely many solutions, okay? That is your clue. If you get something that is mathematically true, that is going to be infinitely many solutions. Versus if you get something that is false, you get something like, 3 equals 8. Or negative 3 equals 0. Those are false statements. Okay, if I get something like this, that is my clue that there are no solutions there. That's my hint. So let's kind of look at what I'm dealing with here. So start off simple. Y equals negative 10. So up above, I'm going to take 10x plus 2 times negative 10 equals 10. So now it's just a matter of solving. So 10x will equal 30. Divide by 10, divide by 10. X will equal 3. And I already know y equals negative 10. There's my answer. That's it. That's all I'm doing. Okay. So now, a little more complicated here. I want to go for substitution once again, because I have y equal to something. So now I will keep the 15x minus 5y equals 30, except now I'm going to swap in 2x plus 3. All right, that's going to equal 30. So now when I distribute this through, that's going to equal 30. So this becomes 5x. So I'm going to add 15. So 5x equals 45. So one-step equation, x will equal 9. So x equals 9. I know y equals 2x plus 3. So y equals 2 times 9 plus 3. So y should equal 21. There's my answer. And again, all this stems from, I have y equals something, so I'm just substituting that in for that y. Okay, so elimination, this is one where things get a little bit trickier. You can manipulate one or both equations. And the point is, you want to get same number, opposite signs. Okay, so if I want something, I want something like 4x plus 3y equals to some number, but then the next one I want like negative 4x minus 5y equals some number. I want this situation where I've got the same number but opposite signs. Okay, so I want that, then I'm going to add the two together, solve for what's left, go back and figure out the first one. Okay, so that's kind of what I want. So elimination is exactly what it sounds like. I'm getting rid of one just to go back and figure it out later. So here, I am looking around. So right now I notice I've got a plus 5 and a minus 5. So I don't have to do any manipulating. I don't have to I don't have to multiply anything by anything, so I'm good in this situation. So what I want to do here is just straight up add those two. So I end up with 7x. This goes away, equals 14. So 7x equals 14, so divide by 7. So x equals 2. So now I can go back and I can figure out, and it doesn't matter which one I do, I will get the same answer no matter which one I substitute it into. 4 times 2 plus 5y equals 6. That is 8 plus 5y equals 6. 5y equals negative 2. So y equals negative 2/5. Let me just double check and make sure that I'm good there. 4x plus 5y. I got 4 to be 2. That looks correct. 6 minus 8. Yep. So I would be 2, and negative 2/5 would be my answer. Okay, let's take a look at this one here. 3x minus 4y. 5x plus 7y. Okay, so right now, not a lot. Nothing, I don't have any matching pairs. I don't have anything like that. I'm going to actually have to multiply both of these by different numbers to see what I can get. So, but you do notice I have a negative 4 and a positive 7. So I do have the opposite signs there. That's okay. I can deal with that. So I'm going to do is multiply this one by 7 and this one by 4. And all I merely did was multiply by the other coefficient. So I multiplied by 7 because there's 7 here. I multiplied by 4 because there is 4 here. So that becomes 21x minus 28y equals 70. Make sure you take this all the way through. Down below, 20x plus 28y equals 12. Again, all the way through. So that becomes 41x. This goes away. This becomes 82. A little bit of quick division. And I get x to be 2. So now 3 times 2 minus 4y equals 10. Again, instead of x, I know what x is, so I'm substituting it in. So that becomes 6 minus 4y equals 10. Subtract 6, subtract 6. Negative 4y equals 4. I get y to be negative 1. 10 minus 6, yeah, 2, negative 1. That's my answer. That is my answer. Okay. Find P and Q so that this figure is a parallelogram. Parallelogram, remember, has opposite sides are equal. So 2P plus 3Q equals 18. And on this side, 5P minus Q equals 11. Now, there's a couple different things I could do. Like I have a negative Q there. I could do some manipulation. I could add Q to the other side. I could bring 11 over. I could do substitution. That would be fine. I could totally do that. What might be easier, so I mean just, add Q to both sides, subtract 11 from both sides. So all of a sudden 5P minus 11 equals Q. So then I could take this, throw it into here for Q, not for 3, for Q, and solve from there. I could absolutely do that. That would get you the same answer, okay? That would be fine. What might be easier, or a little bit easier to understand at least, is if I bring this here, 5P minus Q equals 11. If I notice I have 3 and then negative Q, I want to multiply this thing by 3. Okay, and in doing so, I get 15P minus 3Q equals 33. This becomes 2P plus 3Q equals 18. Okay, so I kept the top as it is. Bottom one, I manipulated, I multiplied, all for the sake of getting 3's next to Q. Okay, I got a positive 3 and a negative 3 next to my Q. So down here I get 17p. This goes away. 33 and 18. I get 51. So I get p t equal 3. So now I'll go back to, I know, again, doesn't matter which one. I'll go back to here. 5 times p minus q equals 11. So 5 times 3 minus q equals 11. So 15. So negative q equals negative 4. I get q to be 4. Be careful with the sign. Be careful with the sign. That negative stays with it. Okay. All right. Now you may go get to work. Thank you very much. I look forward to your questions.